Hi all, welcome to my channel. Today we'll discuss about the Week 1 Assignment 1 Database Management System course solutions. So today I'm going to explain about Week 1 Assignment 1 solutions. So in the very first question what we have, consider the SQL statement below. S1, create table students, students ID, number of 5, student name varchar 2 of 20, address varchar 2 of 20, email id varchar 2 of 20. S2, delete from students where SID student ID is equal to 10005. So in this question they have given two instances. First one is the S1, second one is the S2. In the S1 they are going to create the table. The name of the table is student. So in the student table, we are going to have attributes SID, SName, address, email ID. So total we have 4 attributes are there. If we look at into the S2, delete from students where SID is equal to 10005. So as per this S1, we are going to create the table. As per this S2, we are going to delete the data from table where 10005 is ID. Okay, so where 10005 is the student ID. Now what is the question they have given? A, both S1 S2 are DDL queries, both S1 S2 are DML queries. S1 is a DDL query, S2 is a DML query. S1 is the data control query and S2 is the DML query. So here you see S1 they are using create, in the S2 they are using delete. So one of the important chart for this database languages you must remember. So database languages. So in the database languages we have very important one. DDL is there, DML is there, DCL is there, and TCL is there. In the DDL we are going to have different commands. First one is here we have create, second one is the alter, third one is the drop, fourth one is the rename, and last one is the truncate. So these commands are belongs to DDL. When you see DML, in the DML we are going to have here first one is the select, second one is the insert, third one is the update. In the DCL commands we have grant and revoke. In the TCL we are going to have commit, then roll back, then we are going to have save point. So remember this is one of the important database languages. So first one we have data definition language, second one is a DML, third one is a DCL, fourth one is the TCL. DDL nothing but data definition language, DML is the data manipulation language, DCL is the data control language, TCL is the transaction control language. In the DDL we are going to have create, alter, drop, rename, truncate. In the DML we are going to have select, insert, update. In the DCL we have grant, revoke. In the TCL we have commit, rollback, and save point. So in the S1 create is there, in the S2 delete is there. If you see create belongs to DDL, that means S1 is a DDL, S2 is the delete. What is delete? delete is the, here we are going to have one more command, delete. The command delete belongs to, here this is a DML language, so we can say here delete. So remember, DML is a delete. Now create is the DDL, DML is the delete, DML is the delete. So create is the DDL. Yes, S1 is a DDL, S2 is a DML. S1 is a DDL. Yes, both S1 S2 are DDL. No, both S1 S2 are DML. No, S1 is a DDL. Yes, S2 is the DML. So correct answer for this question is answer C. I hope this is clear for everyone. Let us move on to question number 2. So what is the question we have on the screen? Identify the valid primary key for the following relation. So here they have given some relation. The name of the relation is, the name of the table is students. Total how many attributes we have? One attribute, two attributes, third and fourth. So total we have 4 columns are there. In this we are going to identify the which is the primary key. Student ID, student name comma address, student name comma department name. First you remember what is meant by primary key. Primary key will uniquely identify the table. So when you see in this table, if I select primary key as a SID or student ID, remember it should not have duplicate values. If I select student ID S 10001, 10002, 10003, 10004, 10001. So there is something like duplicates are there. Duplicates means same copy will be available. Second one, 10004, 10004 again. So we cannot say SID is the primary key. S name. So what is S name? Rohan, Kartika, Anindita, Rohan, Pankaj. Yes, Rohan, same names coming 2 times. So we cannot say this is also not a primary key. If you see student comma address, so student name comma address, Rohan Punjab, Kartika Bihar, Anandita Mumbai, Rohan Punjab. So Rohan Punjab, same names are there. Hence we cannot say this is a primary key. But if you see student ID, department name, so 10001 Bengali, 10002 physics, 10003 history, 10004 chemistry, 1001 chemistry. So in the 1001 we have Bengali, 1001 we have chemistry. So 1004 geography, here 100 chemistry. So we can say student ID and department name is called as a valid primary key in this relation. Okay, so here the correct answer for this question is answer D. Let us move on to question number 3. So what is the question we have on the screen? Identify the correct statement. So here logical schema defines logical structure, logical schema defines physical structure, physical schema defines overall logical structure, and view schema defines interaction between the end user database. So now the important point, there are 3 schemas: physical schema, logical schema and view schema. Logical schema defines overall logical structure. Yes, this option correct. Logical schema defines physical structure. No. And physical schema defines overall logical structure of database. No. View schema defines end user database. So remember there are 3 schemas. First one is the physical, second one is the logical, third one is the view. So physical used to define about the physical structure, logical is used to define the logical structure, view is used for the interaction between end user and database. Okay, so this is a final answer for this question is, the answer is A and D. So both options are correct. A as well as D. I hope this is clear for everyone. Let us move on to question number 4. So in the question number 4, what we have? Now you can observe the question number 4. So what is the question? Consider the relation mountain details, mountain name, altitude, state name, where super keys are mountain name, altitude, mountain name, state name, mountain name, altitude, state name. So they have given one table. The name of the table is mountain details. In this, super keys are mountain name, altitude, mountain name, state name, mountain name, altitude, state name. So total how many super keys are there in this relation? So here this is the first super key, second super key, third super key, fourth super key. If you see the options, mountain name, altitude, state name, they have given this one, first option. Mountain name, state name, they have given this one. Mountain name, altitude, they have given this one. So remember one of the important point, what is mean by candidate key? So they have asked candidate key. Candidate key nothing but minimal super key. So out of all these, which is the minimal super key? So in this, the minimal super key, can we say mountain name, altitude, state name is a minimal? No, because it contains three attributes. Mountain name, state name, can we say is a super key? No. No. Candidate key? No, because it contains two attributes. It contains two. But if you see mountain name, it is having only one attribute. Hence, we can say the correct answer for this question is D. So remember, candidate key nothing but minimal super key. So they have given super keys. Out of all super keys, we have to select minimal super key. So minimal super key nothing but here mountain name. Let us move on to question number 5. So what is the question they have given? Students SID, SNAME, address, email, and enrollment. SID, department name, enrollment date. So there are two relations they have given. Student ID is a foreign key in enrollment relation, refers to students. So here, which of the following relational algebra expressions would necessarily produce a empty relation? So let us say there are two tables. First table name is students. In this, we are going to have student ID, address, as well as email. So total how many attributes are there? Three attributes are there. Second relation, what we have? Enrollment. So in the enrollment, what is going to be happened in the enrollment? We are going to have the table. In this, we are going to have again student ID, comma, department name, comma, enroll date. So again it contains the three attributes. How many attributes it is going to have? It is going to have three attributes. So remember, there are two tables, students as well as enroll. Now they are going to say out of all these A, B, C, D, which one will give the empty? If you select this pie, it will select the columns. So I am going to select the columns of this SID, and I am going to select the columns of this SID. Okay, so when we say columns of SID minus columns of SID, enrollment minus student. So here whatever the data we have, in this also we are going to have same data. So the correct answer for this question 5 is A, because when we select student ID enrollment, student ID from students, it will give the empty relation. I hope this is clear for everyone. Let us move on to question number 6. So what is the question number 6 we have on the screen? Which of the following statements is correct? View level abstraction describes the how records is stored. View level hides the details of data types and focuses on interaction with the end users. Logical level describes the what data is stored in the database and their relationships. Physical level relation abstraction describes what data is stored in this relation. So in the sixth question, view level abstraction describes how record is stored. This is incorrect. View level hides the data. Yes, it is correct. Logical level abstract what data is stored. So logical level, yes, this is also correct. Physical level describes the what data. So here physical level data is stores the. So in this there are three levels: physical level, logical level, and view level. So view level abstraction hides the. This is correct. Physical level abstraction uh, describes the. So there are two things. One is what data is stored. Second one is the. So here physical level data stores what data, but when you see logical, it is going to show how the data is stored. Hence, this answer is correct. Wrong. So the correct answer for this question is B and D. So once again, first option what we have, view level abstraction describes the how record is stored. This is wrong. View level hides the yes data types and focuses on interaction with the end users. Logical level how data is stored, wrong. Physical level data is stored, what data is. So correct answer for this question is B and D. So let us move on to question number 7. Now you can see here what is the question they have given. Consider the relation. So name of the student relation is student details, student ID, student name. So there are two things, student ID and student name. If the student ID is a foreign key in the relation of exam results, so which of the following is a valid for exam results? Now, when you see foreign key, so what is the meaning of this one in this relation? SID comma S name is there. If the SID is a foreign key, yes. If it is the foreign key, then which of the relation is going to have valid instance? So if you see student ID, so student ID here 101 and 102. If you see in this relation 101 is there, 106 is there, so we can eliminate this one, this relation. If you see in this relation, we have 103 is there, 102 is there. So this is also we can eliminate. Now, if you see in this one, we are going to have IDs. So exam ID is 1, exam ID is 1. We can also eliminate this one. So final answer for this question is D. This is a important thing. So we are going to eliminate the options first, then we can find the final answer like this. So this is for question number 7. Let us move on to question number 8. Now you can see the question number 8 what we have. There are two tables, chart 1 details, chart 2 details. Identify the correct option which of the producing this relation. So here chart details 1 minus chart details 2. If you remove 1 minus 2, so sender ID is there, receiver ID is there, text ID is there. So 1 1000 means this will be removed. So 1 2 3 1200 2 3 1200 1 to 500, 1 to 1500 is there. So the correct answer for this question is, so we are going to have, so first if you do union between these two as well as intersection these two, so finally you get this answer when you give the intersection for this one and this one. This is the correct answer. So when you find union, how to do this union, what is going to be happen, you combinedly write this table as well as this table, so all details will come. Intersection, both in same values will come again, so same values are, if you do union, what is going to be happen, 1 0 0 1 1000. Let me explain here with one example. By the way, you will get more clarity. Now you can see I am going to explain in a separate page. So what is the first table? First we are going to have S1 and union S2. You see, we are going to find out chart S1 union S2, then S1 intersection S2. So when you say S1 union S2, what is going to be happen? So let us say sender ID, receiver ID, check total, text. So we are going to have union now. We are going to find the union. Okay. So when you find the union, what is going to be happen in this problem? So combinedly, I am going to write all the values. So first one is the, in the given one, R001, S001, 1000. Simply, we are going to add these two tables. So first table union, second table means both values will coming into the place. So just I am going to write here R001 1000, R002, S003 1200. Then we are going to have R001, S002 500, R003, S004 700, R004, S005, then 1400. Now I am going to add one more table for this one because of this union. So this is the first table. Now I am going to merge the second table. So you see in this problem, we are going to have two tables. First table, second table. Just I am going to merge both values here. So just I am going to merge here. When I merge, I am going to get again R001, R002, R004, R004. So S001, S003, so 2, 4 here, 3 here. So S3, S002, S001. So 1200, 1500, 1700. Last one R004, S001, 1800. So this is a S1 union S2. How this came? Just we are going to merge two tables because of this S1 union S2. Now we are going to find the value of S1 intersection S2. So when we find the S1 intersection S2, what are the common values between these two? R1 S1 1000, R1 S1 1000. So this relation will come. R2 S3 1200, R2 S3 1200. This will come. R1 S2 500. So it will not come. R3 S4, R3 S3. It will not come. So there are only two relations. R1 S1000, R2 S3 1200. So when I say S1 intersection S2 is S1 intersection S2 is sender ID, receiver ID, total text. So in this we are going to have only two values. So first one is the R001, R002, S001, S002. Next 1200, next 1500. So remember, we find the values of union between these two, intersection these between these. Now we are going to find the common value of intersection between this one and this one. So now if you see the common values between this one and this one, so R001 S1, yes, it is there. This is where we have S001 with 1200, S00 with 1200. So now we are going to find the value of this R002, S002, 1500, R002, S002, 1500. So first we find the value of union of this table and this table. We are going to get 1 S1000. So 4. Then we are going to have 1000. Now what we have to do? We are going to find the intersection between these two. So intersection between these two values are now S1 intersection S2. Now is there any common relation between these two? S2 as well as now. So we find the final value of this problem. So S1 union S2, this is S1 union S2, it is the S1 intersection S2. Now if you common thing between these two, 1 R001 S001 1000, R001 S001 1000. So it is a common value R2 S2 1200. So here R2, this is the S3 actually, this is one. So R3 S1 1200. So R3 S1 1200, this one. So final answer for this question is, so like this is a way to find out the final answer for this problem. Now let me move on to question number 9. So what is the question they have given? Consider the following table. They have given sender ID, receiver ID, text. Identify the relation which produces the following relation. If you see here 1000, 1200, 1400, they have given 1000, 1200, 500, 700. Directly we can say this is nothing but greater than or equal to 1000, greater than or equal to 1000. Now what I am going to do in this one, you see text is greater than or equal to 1000, with chart details. Directly we can say this answer greater than or equal to 1000. If you see here 500, 700 only skipped. Moving on to next question. Question number 10. So for this question, the answer is we are going to have sender ID, receiver ID, text name. Identify the legend which produces the following. So they have given R02, R04, R02, R04, S03 as well as a S04. So it produces only 1200 as well as a 1400. So if you see here, it is the greater than 1000. It is the greater than 1000. It displays the sender ID as well as the receiver ID. So it produces the sender ID, receiver ID. Hence this correct answer is C. Okay. So this is a way to find the problems in DBMS assignment 1 NPTEL. Thank you for watching this video.